Right. Good evening, everyone. Thank you. Why is this not working? Anyway, today I'm going to be presenting the technology called Augmented Reality, or AR for short. I'm going to explain about the fundamentals of Augmented Reality and the general implementations of AR and possibilities with the gaming industry with Augmented Reality. Thank you. So I would like to introduce myself. My name is Hristo Tarnev. I am a bachelor software engineer. I'm here with Incineration Productions. And sorry, I'm a bit nervous, sorry. I graduated in the Netherlands and I'm currently working as a game developer for Incineration. So I'd like to start by asking all of you if you can raise your hand if you've heard about AR before. I think you guys should come here and present instead of me. Okay, and how many of you have worked with AR projects before? Okay, so not that many, okay, perfect. So first I would like to clarify the difference between augmented reality and virtual reality. In both cases, it could be used at home. So, yeah, you could be sitting at home and you could, in the case of VR, you could have your goggles on and you can be in a virtual world, have a really nice experience, play with some other players, multiplayer. But in the case of augmented reality, you can use a smartphone or any kind of again, headset, but then the difference is that the interaction is with the real world environment rather than a virtual world. So there's basically three types of AR that we use so far, or that we know so far, that we've discovered. There is the geospatial AR system, and that's about the location of the user or the cell phone, depends on where the technology is used. It's based on the location of the real world location of that device. The second one is based on 2D markers or 2D printed pieces of paper which you can view AR objects on. And the third one is where you interact with the real world environment, or like the 3D objects of the real world environment. So like tabletops, or in this case engines. So the general implementation of augmented reality is using a smartphone device, and that's because it's very easily accessible. It's very easy to basically write code to make applications for AR with a smartphone, and that's why it's very used. So here I wanted to show you an example of AR without the smartphone. And this is the Microsoft HoloLens. So it's basically a headset which you can put on your head, and then it has a bent display in front. It has depth sensor inside, so you can track the environment around, and it starts. Yeah, it's basically displaying 3D objects in front of you, so you can see and interact with. And there's a lot of implementations with it. Also, NASA is working with it, and a lot of other industries, a lot of other companies. In this case, it's an example at home and at work. This is Minecraft, actually, if you haven't noticed. And another example I'd like to give you is of augmented reality is the Microsoft Kinect for the Xbox 360. There is also a newer version of the Kinect, which is for the Xbox One. In this example, this guy is in front of a TV with this device. He's looking at himself, and he's basically getting the Iron Man suit, and he's playing around with it. And again, this technology is also not a smartphone. It's using a depth sensor in order to do that kind of stuff, and it requires an Xbox to work. So another example, which I did my graduation on in the Netherlands, is the Google Project Tango. And apart from the other ones, this is a smartphone device. And what's different than normal smartphones for this one is that it actually has a built-in depth sensor which can track the real-world environment, same as the previous technologies. What's cool about it, it can actually do stuff like measuring at home. It can scan rooms, so you can scan your living room and then go to a studio or go to a shop and then decide what kind of sofa you want or what kind of desk you want. It's very accurate, actually. It's, I think, 0.1 millimeter of inaccuracy, so it's quite good for now. I don't know if the project will still continue. I have to ask Google about that, but it was a very interesting project. I would like to give an example, one of the examples for a AR game. There's plenty out there, but this is the one I could think of that's recent. It's The Walking Dead, and in this case, they're using it at home, or like this guy is at his backyard or on the beach, and what they're doing is just looking through their smartphone, to their smart device, and they're seeing a bunch of zombies, and you can switch weapons and shoot them around. It's very cool. So this is an example of gaming in the AR industry. I don't know if you guys heard about this one, or if you've played it before. It was a big boom when it was released. It is considered to be AR. However, in my opinion, it's not true AR because it's only utilizing the gyroscope of your smartphone in order to display, in this case, Pikachu. And you can turn that off, so it's basically static, and you don't see anything if your phone is too slow or you don't like to see it. So it's not necessarily up to the capabilities of AR that we can reach today, which I'm going to show you in a bit. But it's a good example of AR, of a popular game for AR. Do you guys know this one? In a way, this is also AR. It's again a little bit different because it's using facial recognition and image processing vision in order to augment. It's augmenting again this mask or other kinds of filters on top of people's faces. So it's a little bit different, but it's still AR nonetheless. So now going back to conventional AR, I'm gonna show you an example of markered AR and markerless AR. So markered AR we don't use that much these days because it's a little bit boring. There are some implementations for it today still, but mainly we're using the markerless one, and that's because we now have in our pockets a capable device that can do this technology without a problem. And I'm going to explain the problems of it as well. So the markered one, it requires this kind of marker to be printed out and given to the user. And then you can place that marker somewhere on the wall, on the ground, and then via an application, in this case a tablet, you can see something, in this case a thing. Markerless AR, more interesting one, doesn't require this printed piece of paper, which actually allows us to much more possibilities, much broader possibilities. You now no longer need the user to download a picture and then print it out, put it somewhere, and then use the application. You can basically do it in almost any kind of environment as long as there is light, in the case where the device doesn't have a depth sensor in it. So the first one with the picture that I showed you is the markered AR. It's actually using a marker, and it's based on key frames or key elements in that image in order for the smartphone or smart device, whatever the AR is on, the hardware, in order for it to recognize the differences in the picture. So in this case, when you pass this through a specific kind of software, it spits this image out, and you can use that as a marker afterwards. So it's very important that the image is of good quality, so it could be recognized by the smartphone. And yeah, so this is my bad Photoshop skills, but it's like an example of how it would work if you had such an image and then you look through it with an app or something, and then it recognizes the image and augments something on top of it. And similarly, oh, that's not the slide. Okay, it's not a QR code, popular to many believe. It's not a QR code. It's not necessarily a QR code. It could be a QR code. So if you were to feed this image to the software, it will actually give you a marker where you can print out and give to your friends to or users to augment on. So this is how markerless augmented reality works. As you can see, there is no marker. In this case, this girl is using it on her tabletop. And so similar features are recognized. They are not shown as such features, but they're shown as dots in this case. But this is a much better implementation because it doesn't require a marker of any type. So basically, you look with your phone, you look at a table, you let the device recognize the surface, and then you can start placing objects based on your application. Okay. So what's interesting about this is AR Core. It's again by Google technology, but it doesn't require the phone to have a depth sensor in it, which is really cool. And now these depth sensors that I promised about. So all of these technologies, most of which I showed you guys, I think I didn't show you the Magic Leap one. They all use a depth sensor, which is very important to remember because without that depth sensor, the AR wouldn't be that accurate. So the depth sensor is basically a tiny camera that's shooting out IR rays, so infrared rays. And based on the length of those rays, based on the time that they hit an object, it calculates the distance from the user to the hardware. So that's most of the non-conventional ways to connect the HoloLens and the Tango. I also wanted to show you an interesting technology that could be found, or interesting software that was made for the iPhone X currently. And so in this case, the guy is browsing his phone using his eyes only, and he's switching through buttons. So he's clicking buttons by blinking. So what's happening here? This is the example of iPhone X, and this is, I believe, maybe the first phone that came out with a front depth sensor. Could be wrong. But yeah, it still has a depth sensor in front, so it has an IR blaster that you can see. I think it's like a tiny red dot on the device, and it recognizes his face, and yeah, you can do cool things like that with AR. So in order to develop for this technology, in order to get started, you can use several dev kits. There's a lot of tutorials, a lot of interesting stuff online you can find. The most conventional ones for markered augmented reality is Vuforia and Kudan. They could be both used with Unity and Unreal Engine. And the one for markerless is the AR Core and AR Kit. It's respectively by Google and iPhone and Apple. So I think, in my opinion, there's a lot of potential in the gaming industry for augmented reality. I tried here to show you an example of Minecraft normal 2D style and then augmented on your desktop. There's a lot of potential of AR for other industries as well as the educational industry and yeah, other tech industries. And yeah, I believe this would conclude my presentation. Thank you. Any questions?
So short answer, AR code or AR kit?
AR Core. AR Core because I think the way that they use the technology, so the way that it's written, it's very very intuitive, and they really try to use the most out of the device. All the sensors of it, all the proximity sensors, the gyroscope, everything. So in my opinion, it's really good.
Hey.
Hi.
Perfect. So how long before we see a AAA AR game? Because to me, none of what you showed is viable replacement for anything in the established genre so far.
I do believe there are some studios that are working on such games. I know that the technology is not that fast, or in this case, AR is not that fast. They are working on it and they're showing some examples of it. I can't quite remember all of the studios that they're working on it, but I can tell you that it's a new future, I believe, for the gaming industry, because it's unlimited. It's not limited to your input by your fingers on specifically on the smartphone. If you're talking about the smartphone, so it's yeah, it's more of an unlimited area of gaming. So you can, as an example, I showed you the Walking Dead. So you can do it outside. You can walk around the whole city. Also, Pokemon, you can walk around anywhere in the world.
Yeah, but that doesn't actually feel better than the established way of playing with a mouse and keyboard or a joypad. So walking on the beach is not the gamer experience that I know of. And as you said, Pokemon Go is not actually an AR game. It has an AR gimmick to it, but that's all that AR is so far.
Yeah, you're right. It's not what you expect, but in the beginning, the guys that were presenting first, I think, said it, that there is a market that cell phone or smartphone is the #1 bestseller, and that's why I'm giving you an example of AR with a smartphone and not necessarily with a computer with a keyboard.
Sure, thanks. And one extra question: are you gonna use that in the game jam? Are you gonna go AR core, for example?
Maybe. I'm not sure if I'm allowed to disclose. So maybe I'm gonna do an AR project. Yeah.
Cool.
Thank you. Yeah.
Can we just jam a phone into one of these like homemade? Yeah. Okay, this one.
Cardboard.
Cardboard thing is to use like the front-facing, actually the back-facing camera.
Yeah.
Walk around the streets like a total lunatic and maybe play a game while everyone else thinks I'm weird.
Yeah, that's possible. Actually, that's the way that the head-mounted displays for AR first came out. It's actually via this technology. That's what enabled it, or at least that's a speculation for it. So they jammed a phone or a smart device with a display on top of some kind of headset, and then you're able to view AR with your smartphone. The resolution is not the best, but it's still AR.
Awesome.
Yeah. Do you plan to use AR in your next game? In Incineration, I mean. Not on the game jam.
Yeah, I plan to make an AR game with Incineration, that's true, but we haven't discussed where exactly it's going to be placed in the future.
So it's not planned for this current game, the one with the dark girl and sorry, I don't remember the name of the game exactly.
Third Omen.
Yeah.
Yeah, it's not. I don't think it's planned for Third Omen, but we are discussing future possibilities with AR in the game industry.
Okay.
Okay, if there is no more questions, thank you very much. No, there's one more question.
Yeah.
Hey, hello.
Hi.
I'm wondering, is there an universal AR reader, like the QR code reader? Because as far as I know, now to view a 3D model, for example, you have to download a specific app for the purpose. I mean, is there like a universal solution like the QR code readers?
Actually, funny you ask. I think iOS has it in their camera, built in, like a built-in app, a built-in plugin for their camera, where you can scan QR codes without needing to download any third-party apps from the iTunes store in this case, which is really, I think, really cool and really smart, because then it enables everybody to look at a QR with their camera, and it's no longer necessary to download any other app. For AR, I'm not sure. I do believe they're gonna think of this kind of technology because it's gonna be really useful, instead of just looking at normal QR codes or whatever, just to pop stuff up at home using your basic camera application. That would be cool, right? So I hope they do it. I think they're gonna do it. I don't think there was any discussion about it officially.
Thank you.
Okay, if there's no more questions, thank you very much. Okay, one more? Okay, thank you very much, Hristo, for your question.